We were asked by the Leonardo Energy during some conversations we had to write some manuals on several topics which can be used for your house. And you can, don't know if you have already downloaded on the Leonardo Energy site manuals about PV systems, wind, small scale wind, and heat pumps is also one of them. During this session I will tell you some basic information which already was mentioned in the how-to manuals, but still, since the manuals are downloaded very often, we saw that there was a need to have a webinar, and well, thank you for recording it. So I only have to do it once, I think. The purpose of this manual, of this webinar, is to tell you something about the basic knowledge about heat pumps and how they are used within Europe. So I also noticed that some colleagues from outside Europe. I'm sorry for that. I focus on Europe, but since the basic principles are similar, I still think that you can also use it. During this webinar I will tell you more about the air source heat pump, that I focused within the how-to manual on the air source heat pump, but still I will tell you also something about the other types of heat pumps. Agenda for today: I will start with an introduction, I already did. I will give you some overview of the heat pump systems which are used in Europe and on which location they are used. I will tell you something about the technology of the air source heat pump, how they are working and how they operate. I will also tell you a little bit about the coefficients of performance of heat pumps. Some basic information about when you want to use a heat pump within your house, what kind of installation problems or maintenance or operation problems could you have. And finally, Sergio already told you, we will have also a case study with the RETScreen, which will be performed by Sergio. Well, to tell you the truth, what is a heat pump? Well, basically it's an electrical device that extracts heat from one place and then transfers it to another place. Please note that the heat pump is not a new technology. It has been used around the world for decades. I think the most common in their houses. If you look at the basics for a heat pump, from how is it possible, how does it work? I think most of you will know a bicycle pump. If you have the picture on this side, sorry, I have to do it right. On this side, you will see that if you push the bicycle pump down, you will notice that the air will be compressed, and if you take a very good look, you will see that on this side the heat on the valve side will be the air on the valve side will be warmer compared to also work. And you can also do this, it's reversible. If you have a gas and you expand it, it will getting colder. So basically, I think if you understand this principle, I think you will understand how a heat pump in general will work. Also, I mentioned that the air conditioning system is also one of the heat pumps I think most of you perhaps will have in their home. On the front side we will have some cold air. We want some cold air, of course, from an air conditioning, and on the back side, on the other side, the back end, we will have a small pipe or tube, whatever you want to call it, which collect the warmer air from the front side and collects it and make it to a hotter air on the outside. Basically, that's similar for a heat pump. So, how exactly does it work, a heat pump? This figure, I think we have well 4 phases which are recognizable for a heat pump. When you want to transfer heat, you will need a condenser, which is on this side. Sorry for that. Which is on this side. This is a coil where which is called the condenser coil. We also have that. We also have an expansion. If you have a heat transfer and you want to have it to a lower temperature, you need to expand the gas. We also have on this side this side we will have a coil which is the evaporator coil, and next to that we also have a compressor within it, which is located at number 4. The heat pumps transfer heat by circulating a substance which is called refrigerant through a cycle of evaporation and condensation. In one coil, the refrigerant is evaporated at low pressure and absorbs heat from its surroundings. In this case, it's the coil number on this side, number 3. Refrigerant is then compressed on air by the compressor over there, and where it condenses over here in the condenser coil to a higher temperature, and at this point it releases the heat which it had absorbed on this side and transferred to this side. Refrigerated and air conditionings are, well, examples of the heat pump operating in a cooling mode. A refrigerator is basically an isolated box with a heat pump system connected to it, and the evaporator coil is located inside this box, and usually you call it the freezer compartment. The heat is absorbed from the location and transferred outside, and usually behind or underneath the unit, where the condenser coil is located. Well, that's similar for the air conditioning as shown on the previous slide. Basically, the air conditioning transfers the heat from inside your house to the outdoors. There's one big change between a heat pump and the air conditioning or the refrigerator. The heat pump cycle is fully reversible, and the heat pump can also provide you year-round climate control for your home, meaning that in the winter you have a heating mode, and in the summer you will have a cooling mode. And since if you have an air coil heat pump, you will also notice that even on cold winter days it's possible to have some heat within your house. On my next slide I will tell you something more about the cooling modes which can be used for the heat pumps. In the winter, during winter, you will need a heat pump just for heating your house, of course, which is over there. You will collect some cold air from the outside, but even cold air does have some warm. You can compress it, and then you have some hot air in your house. And in the summertime, you can use it for the cooling. It's similar way. You have you collect your high temperature from the outside, then also go to the inside. You can have the cold area. So basically, you can use it in 2 modes. Your heat pump. And in the cooling mode, the heat pump works similar as an air conditioning. It uses an evaporator to absorb the heat from inside the house and rejects that heat outside to the condenser. So here you collect the warm heat and then go to the condenser, and here you get the hotter heat, the warmer heat is getting out. The refrigerant is flowing through this cycle over there, and also through, of course, to a condenser and a compressor which you have outside the area. If you go to the heating mode, then you will see that your outdoor coil becomes your evaporator, while the indoor coil becomes your condenser, and the air outside, even at 0 degrees, will contain some heat. So you can use your heat from this side, transfer it over there, compress it, and then you get some warmer heat. Please note that it also, if you use a heating system for your house, it can be that during the winter, if you have a cold winter, that you might use an auxiliary heat source. And during the RETScreen business case, I think Sergio can show you when you have to decide to have a backup system, an auxiliary heat source, or when not to have it. So basically from this situation you might notice that an air source, a heat pump, as I've told, are ideal for mild climates. When the temperature changing is not that large, you can use it. If you look at heat pump, the different types of heat pumps. I've spoken about the air source heat pump, which is collecting air from the outside and transfer to the heat and transfer the heat to your home. There are also other types of heat pumps, which I will show you in the following slides. The most important aspect when you consider during the evaluation of the different types of heat sources are the availability, temperature level of your house, and also your annual temperature fluctuation which is outside. And I think also the investment costs are very important when you consider a type of use of your ground soil as an heat resource for your heat pumps enables you to store your energy, to use the energy sourced stored in the ground. Typical these pipes are digged within the ground, and I think about 1 meter up to 1.5 meter is a typical value to dig those in the ground. And you will see that if you have a temperature fluctuation, your ambient temperature is fluctuating. Over there you will notice that the temperature within your ground is not fluctuating similar as you have as your ambient temperature. So this one provides you a more constant temperature on your outside. So it's better compared to an air source heat pump. Please note that you will also see that if you have this kind of systems where you use the ground soil as a system, you will see that you will need a lot of area to dig in all those valves. So if you're living in a city and you don't have enough area, this system can probably not be used. Other types. This one is almost similar. It's a heat pump which uses water from a lake which is in the neighborhood. Lakes are excellent heat storages for solar energy. Is very small, and most applications for lakes are larger applications when you talk about heat pumps. The collector now is located at the bottom of a lake, and you have to take care of that. And in order for lake heating, you have to consider some conditions. The house should be, of course, located next to a lake. With wide access of water. The place of the collector must be free of activities. So if someone is going to fishing over there, you might have some problems. Also take care of ship movements, etc. Because if they have must be deep enough in case you have freezing problems. If the temperature drops down to -0 or more, you will notice that the area on the lake can be frozen, and if you have enough depth, then it will not freeze there. Another system which can also be used is the rock heat pump. That's in the last decade, you'll notice that there's a growing interest of this type of heat pump system. You have a solid rock beneath your house. Not within this rock, and it can be lowered up to 100 or 150 meters. And this one is very interesting if you have an area where you don't have enough space area. Then you can, and you have a rock, then you can go down and take all the energy from below. So I've told you nowadays that we have about kind of types are used, and it's very generalized overview I've given you over here. You will see that it depends also on the local conditions. You will notice that in the northern Europe there is a need for heating which is dominating, and cooling of domestic households is only required for just a few weeks during the summer. And if you look at the southern part, you will see the opposite. There you'll see that most of the time you will need it for cooling of your house, and the heating is only required during a few months per year. So that basically gives you also some information about the different modes you have. You will see that, for instance, air installation. It's almost provided only in southern Europe. I will tell you later on why a large difference of temperature cannot be very interesting to use an air source. The common range is between 3 or 5 kilowatt use. That's a terminal output. If you have the ground soil and the ground rock, you will notice that the range capacity is a little bit larger compared to the other ones, and it's very often used in the northern and central parts of Europe. Lake water, well, it depends of course if you have access to a lake or not. Please note that the most of the installations nowadays are air ones, which are often used. If you look at the efficiency of a heat pump, it's also very interesting of course nowadays. I've also taken this one as the air source heat pump. You will see that over there I've a house, and I want to heat this house. Well, I can collect from the air, I can collect the temperature. I know there is a sun which will shine and warm up my temperature over there, and it can provide me between 2 or 4 kilowatt of air heated. Since I also have a cycle where I need some electricity for the pumps, I will need some input from electricity. I have an estimation made about 1 kilowatt, and the total of heat which is now accessible for my home is between 3 or 5 kilowatt hours of heat. If you look how they take the efficiency of a heat pump, it's always called the coefficient of performance, COP. And in this case, it's only very easy to calculate, because it's nothing else than dividing the total of heat you have over there within your house, divided by the heat you need to transfer. And in this case, well, you'll see that if I have, for instance, during summer, I have a lot of warm heat. For instance, I will have 4 kilowatt hours from the sun, and I have 1 kilowatt hour from electricity. So my total will be 5 kilowatt within my house, and my COP is then the 5 kilowatts divided by 1 kilowatt, so it's equal to 5. You will also notice that during winter I don't have, the sun is not shining anymore that much as I have in the summer, so my total number of kilowatt hours will go down, for instance, to 2, and during winter I have a total input of 3, and then my COP will reduce to 3 in this case. That's also important to realize that during the temperature, the higher temperature difference will get, also the coefficient of performance will reduce. And this picture shows you the idea. On the horizontal axis, I have the temperature difference, so between, you can say, between outside your house and inside your house, and on the vertical axis I have the coefficient of performance. You will notice that if the temperature difference, for instance, you have a cold day outside, -10, and you want to have your house temperature 20 degrees, your temperature difference will be 30 degrees. You will notice that your coefficient of performance will go down, and if your temperature between your ambient temperature and your house temperature is lower. Well, let's say you have an outside temperature of 10 degrees and you want to have your home at 20 degrees, the temperature difference will be 10, then you will see that your COP will go up. So that's very important to know, and if you evaluate some types of heat pumps, please note that you also evaluate the temperature, at which temperature it has been measured. because otherwise the comparison is not very good, I think. If you look at some aspects, well, I already told you, larger temperature, the difference means less COP, and an air type is that's the reason why air type is less efficient at low ambient temperature. I already told you that if you have an air type, you will collect the ambient temperature. If the ambient temperature goes down and you still need 20 degrees, you will notice that COP is low. If you have, for instance, a ground soil type of heat pump or water lake, whatever, you will notice that the surrounding area is temperature is less fluctuating compared to the ambient temperature, so it will give you a higher performance. If we look at the design of heat pumps, there are some issues which we have to discuss. Compared to other types of heat pumps, I think air source heat pumps are relatively easy to install, and they represent an economic investment for existing buildings. You can imagine that the investment for an air source heat pump will be lower compared to, for instance, to ground soil, because then you have to dig within the ground and you have to lay down your pipes. And I think air is everywhere available in the world, so it's more it has a lower investment cost than air source heat pump. But please note that an incorrect installation of your heat pumps will also give you higher electricity bills, poor indoor comfort, and perhaps maybe some maintenance problems. Incorrect airflow across the indoor coil is a common problem in air source heat pump installations, and a lower airflow will affect your cooling and heating capacity, and well, finally, of course, also your efficiency of the unit. To make sure that your heat pump has the correct size, please also ask a heat pump contractor to help you with that, because it's not very easy to have to collect the right size of your heat pump. So always ask an expert, well, can you help me with that? Because if you have a too high capacity for your heat pump, your cycle will turn off more on and off, resulting also in a higher energy use, and also perhaps in a shorter operational lifespan of your heat pump. So, and since it's a very expensive device, I don't think you want a shorter lifespan. Please note that heat pumps also make some little noise. So please, if you buy one, please note that you also have ask for the noise level which they will produce. If you have a newly built situation, well, I think that's very easy to install a heat pump, especially an air source heat pump. When you have an older house, you might have some problems, and then you have to address some issues. I think the most important one will be that your duct systems must be very good designed, and please take care that there are no leakages within your duct system, because otherwise your heat pump will not work correct, as you have mentioned before, and then you'll get a lot of energy which will be lost during the cycle. So please take care of your duct system when you use a heating system within your existing house. If you buy a new house, of course, you should also to take care of that, but that it's more easily to place an air source heat pump. Other items which I have collected from some manufacturers of heat pumps, they are also you also have to address some 4 critical areas. That's what they told me. Take care of the indoor air handler, especially when the airflow, well, I already told you there's an airflow about the fan coil, and it should be well, please take care of it, because there is a forced airflow, and please, if there is any trouble with some aspects which could reduce or have negative influence on your airflow, you probably will get some problems with your heat pump. Also take care of the refrigerant system, especially when you have to change it. Please note also and it's freezing down, you might have some problems with defrost over in your unit, which could have negative influence on your heating pump. So please take care of that. Please know that you also have some issues like if you have a large snow which is coming down. For instance, you have a snowpack of 1 meter, and you have also your outside outdoor unit is located very close to the ground level. You might have some problems with that. Next one, I think the control system, of course. Please take care that you have the thermostat that can turn on the equipment on and off, but also most of them can do it reversible also. If you only have a heat pump which is going to work only for one direction, heating or cooling, doesn't make sense for you. So please take care of that. Finally, I would like to tell you something about the maintenance during your operation. Of course, which you can do easily by yourself. Um, these are well, annual inspection of your dirty filters. Perhaps you can clean it yourself. Also the coils and fans you can check yourself, but you can also ask your service contract to conduct an annual inspection of your unit. And if you ask me what time would be the best time to do it, well, I think at the end of a cooling season or prior before you start the next heating season, of course. As general rules, you have to check your filters and fans once a month, and also make them clean to make sure that it will fulfill their work. Ductwork, well, I already told you that it's very important. You should be inspected and cleaned, and to ensure that the airflow is not obstructed by loose insulation or abnormal buildup or dust or whatever. And please also note that the fans where the heating is getting out, that it's not blocked by furniture, carpets or other items that can block your airflow. Finally, I think my last sheet, heat pump manufacturers recommend also some aspects which you have to take in consideration when you buy a heat pump. And a heat pump works most efficiently when it maintains a constant room temperature and avoid large temperature changes overnight and during the day. Well, I already told you about the COP, the coefficient of performance. If you have a larger temperature difference, you might have a lower efficiency of your heat pump. The system can go to a defrost mode if you have the unit outside your house. Please make sure that it can be covered with ice, and if you have some ice on it, it must be removed, and then it will go to a defrost mode. But during defrost you cannot heat your system or your house, so please be aware of that when you have an air source system. Please also, I mentioned already before, the snow line. If you're living in the northern part of Europe, or you might have some snow over there, which can be very high. So please take in consideration that you have to replace your outdoor unit at a higher location and not at the bottom of your house. And of course, well, I think this one is an eye-opener. Expect the unit to run continuously in periods when low outer temperatures are used, or please use a supplementary heating system if it's not covered by the heating unit itself. Basically, that's my presentation, so I would like to thank you for my part. We will now continue with a part by Sergio, who will tell you something more about a case study he has performed on the heat
Thank
system.
you very much, Walter.
Sergio,
thank you for
the floor is
your
yours.
presentation. So now I will walk you through a case study. I'll try to make it simple. So when I was going through it myself, I realized that a heat pump case study can become substantially complex. So what are we looking at today? We look at residential heat pumps. So you can have heat pumps for big buildings, but we'll look at the more smaller scale, so a residential heat pump. So we look at a household with about 550 square meters and a heating load of about 18 watts per square meter and a cooling load of about 28 watts per square heating needs and the air conditioning unit with a COP of about 3 to answer your cooling needs. So we will replace this base case by a proposed case using a reversible heat pump, and we'll look at we will use a ground source heat pump. So now if you bear with me for a minute, I'll just share my computer screen with you. So in a few minutes or seconds, you should be seeing my screen with a red screen. Developed by Natural Resources Canada. It is available freely on the internet. Leonardo Energy has performed a number of webinars applying this software to a number of other technologies, including renewable technologies and other energy efficiency technologies. It is indeed a very powerful software, and I'll try to give you a small take a look at after our presentation. So as I've said before, we're looking today at ground source heat pump for residential use. This is the main page of RETScreen. So here you'll have the information about your case study, and I have already selected from the project database the project referring to this case study. An important point is that you can select your climate data location. So you just click here and you'll have the opportunity to select the country, province, and the location of your climate data, or the climate data that you want. So just click OK, and you'll have this data into your model. You can see all this data if you click this small button, and you'll have a table with all the air temperature, atmospheric pressure, the important, the significant data for your atmospheric model. So let's close this. And once you have defined your project information or selected one from the project database, all you have to do is either press here on the complete load and network sheet, or go directly to the lower part of the screen and press load and network. So you'll have a new screen. I hope the resolution is enough for you to be able to see the figures and the letters on the screen. If not, this webinar will be available afterwards. Is being recorded and will be available afterwards. You can consult it in more detail. So as I've said before, we're replacing. We're defining a base case for our heating project and for our cooling project. So for the heating base case system, we'll have here the area, 550 square meters, and we have a diesel boiler. We defined seasonal efficiency of 78% and the heating load of 18.4. We assume that part of this, there is also on top of this, there's also a demand for hot water. So we assume to be about 10%. So this data that we input automatically calculates the total heating that we need and the peak heating load. We can insert also the fuel rate that will help us calculating our running costs in a later stage. We can opt for having additional energy efficiency measures. So we can increase the efficiency of our system. In this case, we will not use it to keep it simple, but be aware that you can adopt some extra energy efficiency measures to reduce the heat load of your shell. So the same thing goes for the cooling project. You have the same area. The fuel type in this case is electricity, because you'll have electrical air conditioning unit, the COP I mentioned before, and the cooling load. So with this data, the total cooling needs are automatically calculated, and this will be inputted into the next stage of the model. So according to the climate location that you select, you will have automatically generated a chart with the load of the load curve for your cooling and your heating needs. This for the base load characteristics and for the proposed load characteristics. If we would change, for example, the energy efficiency measures, this curve would change. But let's keep it simple and keep it like this. So let's move to the energy model. So we have defined the base case before. We have now the proposed case. So we will replace our oil boiler by a heat pump that runs on electricity. We have the fuel rate for electricity about $99 per megawatt hour. We're talking about a location in the US, by the way. But this can change. You can change your units here and change your fuel rate and adapt it to your location. So the model calculates automatically a capacity for your heat pump that is necessary to answer your cooling needs. Like Walter said before, you may not be able to reach your cooling needs with a certain rating of your a certain capacity for your heat pump. So you'll need an alternative system to answer your peak load. A good thing about the RETScreen software is that you're able to know whether or to calculate the rating, the capacity of your heat pump to answer that need. So if I enter, for example, here 15 kilowatt pump, then I have a small message, peak system required, meaning that the capacity of my heat pump will answer not 100% of my needs, but as you can see here, 96.2% of my needs. So you have a very good indication whether your heat pump will be effective to answer your needs or not. The same thing goes for the proposed case for the heating system. So this is a reversible heat pump, and you'll have a capacity for answering your cooling and your heating needs. Of course, you need to look at the highest, so you're able to answer the highest of your load curves. You can opt for answering the lower one and then having an alternative system to answer only your peak load, depending on your curve, if it has very high peaks or not. But the important detail here is that you can very easily look at your heat pump, and the model calculates and tells you whether your rating, your capacity of your heat pump will answer your needs or not. So if you look a little bit lower, you have here two charts, the red one for the heating system, the blue one for the cooling system. And if you notice, if I change the capacity of my heat pump for the base load for heating, if I put it a little bit lower, for example 8 instead of 10, you'll see that my curve here, my bar here went down. So instead of just looking at these percentages here, you can see that your peak load will not be answered by the capacity that you're adopting for your heat pump. So let's bring this back to 11, for example. We will not have that problem, and this one to 16, where we'll not have that problem. So we'll have our capacity a little bit over the needs for our load. So an important data here, you will be able to input the incremental initial costs for the two systems that you're adopting. So this will be basically the difference between the budget for the base case, so for your oil boiler, and for the heat pump. So the difference between these two systems. So we'll have here another box for the proposed case system characteristics. So it's basically a summary we have estimated is sufficient to meet our energy, our cooling or heating needs. So another important detail that RETScreen allows us is to make an efficient emission analysis. So when you're replacing your oil boiler by your heat pump, you're changing the fuel. So your new fuel will be electricity. So you'll have, or not, depending on the circumstances that you're working with. But in many cases, most cases, you will have a saving on the CO2 emissions because usually electricity generation has lower CO2 emissions than conventional oil boiler. So here we define that our electricity is generated using natural gas that has kilograms of CO2 per megawatt hour. We also include the transmission and distribution losses because this will have a slight impact. It will increase slightly the CO2 emission factor. As you can see, we go from 439 to 477 kilograms of CO2 per megawatt hour. You can use this data, maybe not in residential unit is not interesting because your CO2 gains will be not so high. But if you have a big complex or a big building, you may have enough CO2 emissions to generate greenhouse gas credits. So then you can trade these credits and have an extra income. So this is maybe, like I said, is mostly interesting for big installations. So just after we have the financial analysis. So you should look, or your eyes should be drawn already to the chart that we have on the lower right corner. So you'll see here a curve with a cumulative cash flow along the running years. So we can define the project life. So we have defined a project life of 25 years. We define an inflation rate for our investment, our debt ratio, whether we ask all the money from the bank or we have self-financing, the interest rate for the loan that we ask from the bank, and the debt term, of course. So you can change all this data and you'll see the respective changes in your cash flow. So the costs that we entered for the additional costs for the heating and cooling systems are shown here. And these are then balanced with the annual costs, both for the running costs, the fuel, and for the debt payments for your loan. These will be balanced with the annual savings and income. So the savings will be basically the fuel costs that you will save from changing from oil to electricity. Another important parameter that you can enter here are the incentives and grants. So if your utility or your government or your region has an energy efficiency program, you may be able to receive some incentives or some grants from investing into a highly efficient appliance product. In this case, a heat pump. And many regions do have these programs particularly for heat pumps. So you should, if you're interested in it, you should investigate that, and then you can enter the amount of money that you receive as a grant, and this will also be balanced into introduced into your cash flow. So this is so I just one small detail. With all these figures, the model will calculate you an internal rate of return. In this case, you have an internal rate of return of 18.5% that gives you a payback of 7.4 years, simple payback in this case. So this is very simply an explanation of the RETScreen model for heat pump. As you can see, there many data that you can input yourself. You can really adapt this to your particular situation and have a very good characterization of your system and a very good extrapolation on whether it is efficient in your circumstances with your heat load with your climate conditions as well, to invest in a heat pump system or not. So I will stop now sharing my screen, and we'll go back to our Adobe Connect. And I will, if you bear with me for a moment, I'll just share again our presentation, just for us to have something on a screen. So here we are. And I've seen, as we were talking, that you have entered a number of questions. So I will start maybe from the first question that were introduced regarding the presentation from Walter. So Richard Helen has asked us about borehole water heat pumps. Um, Walter, would you be available to draw some comments on borehole water heat pumps if you have any information about it?
Don't have actually I don't have much information about it, but it's also a possibility. I'm looking at the questions now. Um, you can use I think it's a combination of your other question and what about air water heat pump. Of course you can. I've talked about the air source, which meaning that you have an yeah, you have your air collected and you go with air outside of inside your house. And you can also use a heat pump, for instance, for your water, for instance, to take a shower or have your water from the to use within your house. Of course, you can also use. I've only discussed about the air, but also you can also use your temperature of your groundwater, which is below your house. You can also use that, of course, as a situation. I've only given some limited information about the types of heat pumps we have in Europe, and of course there is also a possibility to use the groundwater types. I think that's the main question.
Mm. But just another consideration, Walter. So heat pumps are usually used to put the heating liquid to a certain temperature, but they can be used into any heating device within the house. So what I mean is a floor heating or a normal radiator that is hanging from the wall. Am I corrected?
Correct, yes?
Okay, very good. So moving forward, we have another question from Steve Goldberg. So he's asking whether there is a standard temperature difference that manufacturers use when they're expressing the COP of a system.
Question. I've noticed if there is a standard temperature. I didn't ask it myself. I don't know why I didn't ask, because it sounds like a very logical question. I noticed that most of the manufacturers give also a temperature at which temperature the COP has been given. In this case, I have, for instance, I've now have a flyer from an heat pump system which is providing the COP at 40 degrees Celsius and another one at 60 degrees Celsius. So it's, yes, they have some temperature, but you have to take care of the temperature, of course. I'm not quite sure if there is a reference temperature. I'm not sure about that. Sorry for that.
Okay, Walter, but so the COP changes according to the conditions that you have. So a heat pump that your manufacturer says um, is likely to achieve a COP of 4 or 5 may never reach that in your operating conditions, because your in-house temperature is very different from your environment temperature. Am I
Hmm.
correct?
Yes, that's correct. That's
Okay,
correct. But it's also
so do you have an idea of how what is the difference of temperatures for a heat pump to be able to perform moderately well? So if you have an
didn't
in-house
quite.
temperature of 15 or 20 degrees and outside temperature of 0, it will probably still work. But if your outside temperature is -5 or -10, probably here
Oh,
heat pump
that's right. Yes,
will not.
there's a general rules which is saying that it below -20 degrees outside, then you could have a lot of troubles with it. So, but that's a very basic. It depends also on the size. Of course, when you have an air heat pump, you will have to take care of the outside temperature, and if it's going very large down, then you could have some troubles. Because at very low temperature, well, there is still some heat within the air, but it's very limited, of course, when the temperature drops. So in that case, then you will need another type of heat pump. For instance, the types we have mentioned before.
Mhm. Good. So we have another question now from Sohad Kadum, and he asks whether we have an idea on how to analyze the ocean loop. I don't really understand the question here, but um, maybe he's trying to explain how do you dimension, or he's trying to ask how do you dimension the loop that you need to answer your heating or cooling needs.
That's a very good question. I'm exactly is.
So I imagine that when you buy a heat pump, your manufacturer will probably draw a table with the length of your heat exchanger that you need for you to answer a certain heating or cooling needs. Should it be like that?
Could be, could be, could be. You have to notice that within this presentation, I've only given you very limited information. If you really talk about designing and detailed designing, you also have to ask to your manufacturer or to a service provider to assist you with that, because you cannot do it, I think, yourself. Dimension your heat pump. It's not that easy. I know you have given Sergio some examples on RETScreen, but please note it's very hard to have a good design installation, because it's not that easy to dimension your heat system. So if you talk about loops or valves or whatever, the dimension of that, please ask your manufacturer of it. That's very difficult. It depends on the types.
Yes, I gave in my introduction, I gave the hint that indeed a heat pump is very case specific. So whether you have air, water, or ground or rock based heat exchanger, you will have a different circumstance, and then that depends. That needs to be balanced with your heat load. So you actually need a good previous study to know what your heat load is, so you can properly dimension your heat pump. Okay, so we have now another comment. It's more a comment than a question from Fernando. So it says that in Spain there is a new concept, so a heat pump that is directly driven by an internal combustion engine that uses natural gas or liquid propane gas. The residual heat from that gas engine is then recovered and can be used for cogeneration, which brings an added value. And it says that this technology allows the building constructors to reduce the compulsory part of renewables in the building. Are you aware of any other movements in this direction across Europe, Walter?
I know that in the Netherlands there's also a discussion about that, to use the gas heat pumps, which I think is a very attractive one to use. You have both a combination of you can heat the gas and you can also absorb the heat from the gas. So I think that's a promising one.
Hmm. Very good. So we have now another question from Roger van Mienem. Sorry if I mispronounce your name. So he's asking, what about seawater heat and cooling pumps? Is it efficient, technically feasible? So for this question, I think because it is so case specific whether it is efficient or not, it will be technically feasible indeed. But regarding efficiency and cost efficiency, you need to make an analysis of your particular case, and I advise you for this answer to use a RETScreen model to reach a conclusion. Let's move forward. So Jose Pinto asks, are the heat exchangers the same when heating and when cooling?
They are, yes.
So what you do
One
is
of
just to
my
reverse direction of the flowing, correct?
correct. It's if you reverse it, then the coils will go the other way around. It doesn't matter if it's the warming heat pump or it's the warming side or the cooling side. It doesn't matter for the coil.
Mm-hmm.
So it's the similar coil. You don't have to change that.
Okay, so we have another question from Mark Townsend. In the case study, you indicated efficiencies of the boilers in the base case. How do you arrive at that percentage? So this base case is was for a new construction, and what was done before was an estimate regarding the climate conditions that you have of the foreseen efficiency of your boiler according to that heat demand and that climate pattern. So it's just a small study that has to be made before a performance study that is many times given by your manufacturer. So that was the data that was used. So we have another question now from Richard Helen. Does RETScreen allow for the effect of air temperature on the COP? In other words, if RETScreen provides the air temperature data for a location, can this be accounted for automatically in RETScreen? Yes, the answer is yes. So the COP or the rating of your heat pump will be calculated based on the maximum COP that your heat pump can achieve, and this will be balanced with the climate conditions. So the air temperature, the average air temperature for that location will be accounted automatically in RETScreen. So let's move a bit forward. Another question from Guillermo Soveron. So he says that he lives at the coast of the Sonoran Desert. Summer temperatures can get into the 40 degrees Celsius, and winter temperatures can drop to 10 degrees Celsius. So he's asking whether a ground heat pump can be an apartment building, so can answer the heating and cooling needs for an apartment building. Would you mind to answer this one, Walter?
Yes, if you have a ground soil system, I think that's no problem with that because also the ground soil consists the heating and also you can also use it for cooling the ground. That's the large temperature difference will give you a less performance. So your opinion to use is use it. And
Very
there's
good.
also an opportunity because the ground soil has a higher range, so which is also better compared to the air source.
Very good, thank you, Walter. So we have another question now from Angela Ma. She asked, at what scale are heat pump installations most economic? Decentralized or centralized system? So I imagine she's referring to an apartment building where you can have heat pumps per apartment, or you'll have a centralized system for the whole building. Do you have any considerations on this, Walter?
There are some consideration, but I can, I'm not the expert on that one. But I think in general I heat pumps for each apartment over there. So I think you have to combine one bigger, and especially when you have a block of houses, you might also think to use one bigger one instead of using 5 or 6 smaller ones. So if you go bigger, I think it's more efficient for you to use compared to smaller ones.
Mhm. Yes, indeed, but that again has to be balanced with the climate conditions that you will have for a particular case. It may be useful, more useful in northern climates than in southern climates, for example. Very good. So
Agree
we
with
have
you.
another question from Lydia Derlatka. So she's asking, I made a confusion. It's from Valentino Barroso. Is a lake system suitable for Southern Europe? Uh, so I think, Walter, you had a slide on this where you said that air-to-air heat pumps are probably most dominant in Southern Europe, and then the ground heat pumps are more common in Central and Northern Europe. So would lake water heat pumps be uh, more proper for Southern or for Northern climate?
I think, if you ask me honestly, I think more for the northern part, because you lake water, you collect the heat which is provided during summer. You collect it and you want to use it within the winter. So it's more for the heating system, your lake water system. So I think for the northern part it makes more sense compared to the southern part where you already have good temperatures. So I think lake water system make more sense for heating than for cooling mode.
Very good. So we have another question now from Fernando. He's asking, in a building of 30 apartments with collective heating and distribution of hot water to radiators, would it make sense to replace the existing boiler by a heat pump? So I think we've already more or less answered this question. So this is really a case specific. So it depends on the heating needs of that apartment building. And on the climate conditions, then it would make sense to replace that boiler by a heat pump or not. So a specific analysis for that specific case has to be done. So we have another question from Alexander Skrilnik. Does RETScreen take into account solar gains? If yes, what is the manner of solar gains consideration? So my understanding of the RETScreen software is that it accounts the solar conditions as a means to increase ambient temperature. So I'm not sure of the technicalities of this relation, but yes, solar gains are included into the RETScreen model. Then we have another question from Jonathan Barry. Is there somewhere that would help me to calculate the heating and cooling load of my home? For example, I know how much oil I used in a season. Can I then correlate that to my heat load in watts per square meter? Well, yes, you can do this if you know the fuel consumption of your boiler, and if you have an estimation of the efficiency of your boiler and the area of your face, you can make a very rough approximation of the cooling needs for your house. But you can always go into more detail, and an expert will make a very detailed analysis and give you a very concrete heat load in watts per square meter for your house, and this will probably help you to better dimension your heating system. So let's go through the questions. I'm sorry if I'm taking a bit because we have a long list of questions already. We have Jose Pinto, which he is asking which are the best heat exchangers to use if both heating and cooling are to be used. So, excuse me. So I have the impression that it does not really make a difference, because nowadays most heat pumps are reversible heat pumps, so they actually use the same heat exchanger for both the heating and cooling tasks. So there is not much of a difference in the heat exchanger. So I can see you're already a little bit off schedule. The questions offline, will be available on the Leonardo Energy website. So there's a simple question: do you need to insulate the distribution system, the ducts? Well, this is, of course, will affect your the performance of your system, the lower losses you have, the better performant your system is. So the better insulation you have, not only in your ducts, but in your house, in your walls, or in your windows, the better your system will perform. There was another question from Peter, more or less on the same line, so I hope it's answered now. So there is Roger van Nieben saying that there was an inconsistency in the presentation by Walter. He says, sorry, he says here-to-here heat pumps is for mild climates. However, in the following slide, he mentioned for purposes because of lower investment compared to ground and water heat pumps. Could you comment on the investment difference? Could you say something about it?
Oh yeah, sorry. I'm not quite aware about the prices, but I'm sorry for the